Okay, so I just used a regular old cost function and I pulled out the x to the 2n, but if in an alternating sequence, if -1 equals -1, then we use -1 to alternate, and it ends up panning out like that. That's simple enough. Well, you can use I squared equals -1 as well by pulling out the x to the 2n, taking I as your alternator or your operator, and then running it out, and it looks like that. And you end up with these two waves right here. Well, there's more complex numbers, like h to the 4th equals -1, and again, using h as your operator, it factors out like this. And you end up with these waves. And that is what the graph of h squared equals I, h to the 4th -1, h to the 6th minus I, h to the 8th equals 1. Well, then you can move on down to g to the 8th equals -1, factoring it out just to make it simple, using g as your operator. And it looks like this when you factor it out. And you end up with these waves right here. And this is what the graph of G looks like. Now you have descending order, or ascending order, excuse me, of how they equal -1. They go into a 2 to the n pattern, and that's because you don't need it for every even number, because say if you want something raised to the 6th power to equal -1, it's easy enough to do with I squared cubed, and you get into the 6th. And then I wanted to show that our number system actually sits on 3 axes. You have a neutral, you have a positive, and you have a negative. And we actually use a 120-degree number system, and that's the positive side of minus, that's the negative side of minus, the minus side of positive, positive side of positive, minus of